Alright, I've got a bit of a weird one for you today. So, I'm going to show you, firstly, what's a fractional power. That's this, when you've got 7 to the power of 2 over 3. Weirdly enough, this is equal to 7 squared and the cube root of that. So I'm taking the root from this 3 over here, and I'm taking the index of the 7 from the top of my fraction. Okay, you might be thinking that is pretty bizarre. Why is this 3 on the bottom of the fraction turning into a root? Now, firstly, I'm going to show you some evidence that that's true. So, let's do 2 to the power of... So, the power button, and I'm going to do a fractional power by hitting the fraction button. 1 over 2. And that's 1.41421. So you can see from this number, hopefully you remember last time, this is an irrational number because it keeps going on forever. Anyway, 2 to the power of 1/2, and now I'm going to do the square root of 2. And you can see that they're exactly the same number. So that's proof. So this is a square root. The reason it's a square root is because this number on the bottom is a 2. If I did 2 to the power of a third... Oh, what am I doing? 2 to the power of a third, and I did the cube root of 2, you'll also see that they're the same number. Alright, so I've just shown you some evidence. Now I'm going to show you some proof. Evidence is not the same as proof. Proof in maths is showing that it works for every possible question. So let's just prove that 2 to the power of 1/2 equals square root. And the way I'm going to prove it is if I times these two, I can simplify this by adding up the powers. Just like I would do 3 to the power of 5 times 3 to the power of 8, 3 to the power of 2 is 3 to the power of 7. I just add up these two powers. Let's just add up these two. Then I will get 2 to the power of 1. Okay, and let's do the square root version. Square root of 2 times square root of 2. You'll remember hopefully from the last video that if I have two numbers that are two square roots that are the same multiplied together, that's just equal to the number inside the square root. So you can see for both of these, I'm getting the same result. 2 to the power of 1 is just 2. What that means is these two have to be the same. If I put them in the same place in my equation and the same answer pops out, they have to be the same. Okay. This is a pretty strange and difficult topic. We'll do a couple of examples, and hopefully you can do these examples with me and you'll understand the examples, even if you didn't understand the proof necessarily. Alright, so 16 to the power of 3 over 2. Remember, 3 is the power, and 2 is the root. So I might just put it like this. You can put it like that, or this. But I'm going to put it like this for a reason, because we can actually work out, we actually know what the square root of 16 is. The square root of 16 is just 4, isn't it? So that's actually the same as 4 to the power of 3. So you can see that this is already useful. It can already help us to simplify something and work out what it is. 4 to the power of 3 is 4 times 4 times 4. That's 16 times 4, 64. Let's just check that with the calculator. Once again, I want to prove this to you, just to prove that I am not going crazy. 16, where is it? 16 to the power of, and we had 3 over 2, and it's 64. All right. Next one, express 125 to the power of a third in surd form, and then evaluate it. So there's no power on my number, it's just a root, and that has to be a cube root because that's a 3. And you might even remember from the previous video that the cube root of 125 is it's a number that I have to times by itself 3 times to get to 125. It's 5. Okay. That's a lot. Feel free to rewatch some of that video. Ask for help if you don't understand it. And I'll see you soon.